I'd be surprised if you didn't know that whales echolocate. They make a noise that travels through the water, bounces off objects, and travels back to the whales for one reason or another. You've also definitely heard whale song before, and I would be worried for your childhood if you've never seen this. If only Dory could teach us how to speak whale. What would we learn? What wonders might they show us? And what if I told you that we're already doing that? Yes, I meant that. There are some scientists who believe that whales have a translatable language. I learned this a few years ago on one of my YouTube rabbit holes, and now I'd like to share with you what we know of the language so far, if it even exists, some of my thoughts on it, and even what this could mean for our understanding of our place in the world. As for whether or not there even is a language, even the most hardened skeptics like University of St. Andrews biologist Luke Rendell and Christoph Dresser, a science journalist, concede at least to the possibility of there being a language. The only thing they seem to disagree on is how important and complex it is. Rendell thinks we should drop the stifling and anthropocentric focus on language. It crowds out other perspectives on what is going on. For example, the relationship between rhythm-based communication and music might be a better way to understand the bonding function of codosynchrony in sperm whales. He makes a good point that the hype around the language of sperm whales, and other whales for that matter, may be overshadowing another explanation of what's going on. Perhaps they simply make the sound because they like them, and know that other whales like them. Perhaps they don't really know why they do it, and that's just the way God made them. However, this doesn't really seem to be the case. Well, God did make them that way, but it really doesn't seem like they don't know what's going on. Given the extraordinary amount of research in this field, all of which builds on previous work, it seems to me very unlikely that all of it would accidentally line up, like puzzle pieces that, if just a bit of pressure is applied, fit together, even though they're from opposite sides of the puzzle. Alright, now for the fun part. How in the world does this language work? At the same time, we know way more than you'd think and precious little. Honestly, research is a little like trying to squeeze the last bits of toothpaste out of the tube. It's possible, but extraordinarily difficult. Similar to human families, sperm whales have separate clans. They can migrate across great distances throughout the year, and on top of that, they spend a substantial amount of their time deep underwater, hunting their preferred food source of squid. Further complicating things, the clicking sounds they produce through a large hollow cavity in their foreheads are loud enough to kill a human at close proximity. Here's the problem, though. These clicks are exactly the thing that needs to be studied. After all, they do make up the entirety of the language. Sperm whales produce sound exclusively through clicks. We organize these clicks into groups called codas. There's a great video from the Computer Science and Artificial Intelligence Laboratory at MIT, which explains a large part of what we know so far. This video is in fact based on a paper written by a couple of students at MIT. In the research for this paper and video, they found 4 basic elements of a single coda. Rhythm, which is where the clicks are situated in the coda. Tempo, which is the duration of the call. Rubato, changes in clicks relative to the duration. And ornamentation, an extra click that doesn't seem to follow the normal structure of a coda. You may be able to divine why rhythm and tempo are called what they are, but just in case you don't know what rubato and ornamentation are, here are their definitions for Botanica.com. Subtle rhythmic manipulation and nuance in performance. For greater musical expression, the performer may stretch certain beats, measures, or phrases and compact others. The technique is seldom indicated on a musical score, but may be utilized according to the performer's discretion. Rubato may affect only the melody, as in jazz, or the entire musical texture. As for ornamentation, it's the embellishment of a melody either by adding notes or by modifying rhythms. Rubato is changing a piece of music just slightly by changing the length of the notes, and this gives it a different kind of emphasis. And ornamentation is similar, but instead of extending or shortening notes, ornamentation could add notes or different rhythms. I'd imagine certain artists are more prone to different kinds of rubato and ornamentation, which probably is a part of their specific style. You could probably hear it by listening to different renditions of some well-known piece of classical music. Anyway, back to the sperm whales. At the moment, research is still so basic that the system for representing the codas as humans represent words with letters is still undergoing changes. For example, in his paper Vowels and Diphthongs in Sperm Whales, Gasper Begas, an associate professor at the Department of Linguistics at UC Berkeley, presents a visualization technique that allows us to describe several previously unobserved patterns. One of the most interesting players in this quest for communication is AI. Begas had previously created two neural network systems to determine meaning from raw sound input, which he called Sugan and Fugan. In the sperm whale paper, they trained a model of Fugan to determine meaning in sperm whale codas. It discovered some of the known areas of meaning, like the number of clicks and the amount of time between them, which perhaps lends credence to the fact that it also discovered an entirely new aspect of meaning that has to do with differences in the acoustics or specific sound of clicks. Based on this, Begas and his team claimed they discovered a mechanism analogous to the production of vowels in humans. When we make a sound, it produces a certain frequency of air vibration. In the sounds for I and A, the frequency peaks like a mountain. These can be visualized via a spectrogram, which is a graph that plots sound waves. For vowels, there are often 3 lines that appear on these spectrograms, and they are called formants. For most vowels, the 2 formants closest to the bottom are the only ones needed to identify it. Begas and his team labeled the coda templates as I and A because the 2 formants are similarly placed relative to each other. They can confidently state these findings because the frequencies were consistent across all the whales they studied. And this is interesting, because only 10 whales were studied, which is understandable, as getting many recordings from many whales and analyzing all of them would prove pretty difficult. However, at the same time, this may make their findings less credible, as they could all be from the same pod. If they found consistency across multiple pods, I wonder how the frequencies might differ, as the different clans of sperm whales have different tendencies in their codas, almost like accents in human speech. Okay, remember back at the beginning when I mentioned Luke Rendell and his anthropocentric focus on language? I'm going to go back to that. In fact, I believe this anthropocentric focus is exactly what one's mind should be on. One of the 4 pillars of classical philosophy was anthropology, or how humans understand their place in the world. To build a good anthropology, a solid understanding of how humanity relates to other parts of the world is essential, which brings us to sperm whales. If we take as a given that sperm whales have a language, then one could possibly say that the whales are rational. Let's look at some different views on rationality. According to Peter Kreeft's Socrates' Children, Aristotle famously defined man as a rational animal. However, Aristotle does not seem to define rationality anywhere. You see, Aristotle thought of things in terms of, you could say, genus and species. He categorized things based on their general category and then based on what differentiated them from the rest of that category. For humans, he said they were rational animals. Animal is the genus and rational is the species. We belong to the greater classification of animal, but we are differentiated from the rest of the animals by the fact that we are rational. Unfortunately, this means he didn't really define rationality anywhere, so Aristotle is a dead end. Nora Heinzelman, who has a PhD in philosophy from Cambridge University, wrote a paper called Rationality is Not Coherence. In it, she presents 2 current views of rationality. Encrasia, which she defines as intending to do what one judges it ought to do, and persistence of intention, which requires that an agent retains their intentions over time. Heinzelman states how she's found fault with them, and then presents her own definition. An agent is rational or irrational to the degree to which they respond adequately to their available reasons. Under this adequate response definition, most all animals would be rational. A squirrel has adequate reasons for running away from a dog or burying their acorns in the ground. Survival. Unfortunately for Heinzelman, there is fault with this too, namely the lack of a method of judging adequacy. Some of the examples she gives in the paper, such as Agamemnon's dilemma of whether or not to sacrifice his daughter for the sake of his nation in the Iliad, seem to suggest that adequacy is how well your reasons correspond to what you believe is good. The problem with this lies in man's eternal search for what is good. There are many views, and most of them are mutually exclusive in some way or another. For example, a person with an extreme mental disability like dementia might believe they are doing something for sufficient reasons, but a person with no mental disabilities may look on and know that they actually have no reasons. They may even have reasons against their actions. So are they rational or not? Under Heinzelman's definition, there can't really be an objective answer. So what are we to do? I propose a new definition, that rationality is a spectrum, not an attribute ascribed to certain things and not present in others. In other words, some creatures would have more rationality than others. This would possibly fulfill our tendency to think of certain animals as higher or lower. Most people don't think about squashing an ant or fly, but react to the death of a dog, cat, or even fish as if a human had died. Under this understanding, those animals would be higher on the spectrum. Bugs would be much lower on that spectrum, and humans at the absolute top. Alright, so what about the whales? Under this spectrum definition, the question isn't, do they have rationality? The question is, how much rationality do they have? One of the things that separates the top and the bottom of the spectrum is complexity of thought. For example, think about bees or ants. They have almost no thought for themselves, but instead the whole colony acts more like a single organism. I could also bring up superorganisms like siphonophores. These massive creatures are not in fact one organism, but instead a giant colony of hundreds of tiny organisms, none of which could function on their own. I think that should be a pretty big clue as to their complexity of thought. So language being a sign of high rationality must mean that sperm whales must be very far up the spectrum, much closer to us than you'd think at first. Being able to differentiate different parts of speech and derive meaning from them implies a high ability of critical thinking. Now this has a couple connotations. Doubtless we really should work to preserve these incredible beasts in their language, but there must be thousands of writings and videos about that already. I want to focus on how the whales should be studied further. As mentioned before, AI plays a large role in this research, but its downfall is its need for a large wealth of data to draw on. In fact, the hardest part of this effort seems to be the lack of data. There are some dangers and roadblocks to data collection that can't be ignored, such as the extraordinary volume of the clicks themselves and all the other stuff we talked about earlier. Some problems have been partly solved, such as putting microphones on the whales to record them. One hiccup of that method, however, is the lack of situational context. Our end goal would obviously be deciphering meaning in the codas themselves, but when translating any language, especially for the first time, you need context. Think about the phrase, "the bark was rough." We use the word bark for several things: the sound a dog makes, the skin of a tree, and a forceful command on a human's part, as in, the drill sergeant barked. Without a large depth of contextual information, a translator would have no idea which one was which. With most languages, the subject of the sentence is enough context, if we had said, "the tree bark is rough." However, with the whales, we don't really know the meanings of any words, let alone the subject. We don't know which part of the coda is the subject and which is the verb. We don't even know if the coda is meant to be a letter, word, sentence, or even paragraph. We just don't have enough data. All the organizations researching this complex subject are nonprofits. That being so, the best way to help them is probably by financially supporting them. On their website, Project CITED has a donate button where you can choose to give monthly or just give once. The Dominica Sperm Whale Project says that the largest part of their expenses every year is their airfare. They allow you to donate miles through their partnership with Aeroplan. These are perhaps the best way to help these projects sort of becoming a researcher yourself. And even if you don't want to give, your interest makes all of this worthwhile. It shows that Russ's research into things like the structure of codas is a valid pursuit. It shows that Begus's inquiries into what exactly holds meaning in their codas is still important. It shows that after all is said and done for research, there are still pieces for the philosophers to pick up and move around. Perhaps most importantly, it shows that though something holds no immediate social or economic value, we still have a duty to research it, to understand our place in the world. I hope you've enjoyed this little journey into my thoughts on sperm whales and their language. Ever since I was little, I have loved learning about animals. I've loved learning in general. The tendency of a 4-year-old to ask questions never really left for me. This dive into sperm whales is only one period of my travels, and I hope to continue sharing these travels with more video essays in the future. Though with my upload schedule and YouTube work ethic, I really can't be sure if that will happen. If you want to learn more about sperm whales, language, or rationality, I've linked all my research down in the description with references to each time I cited them, and a simple YouTube or Google search can yield more results than you'd think. Anyway, I hope you have a great day or night, and remember, it is the glory of God to conceal things, but the glory of kings is to search things out.